parameters of a probability distribution. Remember that with a probability distribution, we have a description of a population, not a sample. So the values of the mean, standard deviation, and variance are parameters, not statistics. The mean, variance, and standard deviation of a discrete probability distribution can be found with the following formulas. The mean, we take our x value and multiply by p of x. For the variance, which is the same as the standard deviation squared, we take our x value minus our mean, we square it and then multiply that by the probability. And these are really the same. We're not going to do manual calculations, so nothing to worry about. And once we find our variance, our standard deviation is just going to be the square root of that. Let's do an example. This table is going to describe the probability distribution for the number of heads when two coins are tossed. This is the mean. This right here is going to be the variance when I sum them. X, which is 0, times 0.25 is 0. 1 times 0.5 is equal to 0.5. And 2 times 0.25. And this is going to equal also 0.5. Now notice when I add these up, 0.5 plus 0.5, I get 1. Now I know my mean is 1. Now let's do the variance. X is 0, mu is 1, we square it, and we multiply by p of x, which is 0.25. And this is going to equal 0.25. I'm just going to put it out here. I have 1 with my x minus my mean squared times my p of x, which is 0.5, which equals 0. 0 times anything is 0, so this is 0. And then the last thing I have is 2, which is my x, minus my mean squared times p of x is 0.25. This equals 2 minus 1, which is 1. 1 times 1 is 1. And then I multiply that by 0.25. And again, I would get 0.25. The variance is the sum of all these numbers. If I add these up, I get 0.50. That's my variance, sigma squared. And our standard deviation, which is equal to sigma, is equal to the square root of sigma squared, which is the variance. Sigma is equal to the square root of 0.5. That's equal to 0.707. Now I have my standard deviation. When tossing two coins, the mean number of heads is 1 head. If I toss 2 coins, there's a 50-50 chance, same as tossing 1 coin twice. The chance is that one time I'll get a heads and one time I'll get a tails. That's the average, the mean. The variance is 0.5 heads squared, because remember, it's squared. That's why I get heads squared. And the standard deviation, we got 0.707, and here we have 0.7, but they rounded to 1 decimal. Also, the expected value for the number of heads when 2 coins are tossed is 1 head, which is the same value as the mean. If we were to collect data on a large number of trials with 2 coins tossed in each trial, we would expect to get a mean of 1 head. Number 1, 5 males with an X-linked genetic disorder have one child each. The random variable X is the number of children among the 5 who inherit the X-linked genetic disorder. Out of 5, either 1, 2, 3, 4, or all 5. Determine whether a probability distribution is given. If a probability distribution is given, find its mean and standard deviation. If a probability distribution is not given, identify the requirements that are not satisfied. I'm going to click on my little bar here, and I'm going to open this in StatCrunch. Here's my values. First thing I want to know is, are all my X's numeric? Yes, they are. Number 1. Number 2, we're going to have to figure that out in a minute. Number 3, are all my probabilities between 0 and 1? And yes, we can see that all the probabilities are between 0 and 1. Do all these P of X's add up to 1? I can go here to Stat, Summary Stats column, and I want to know if all the probabilities, and we just go to Sum and hit Compute, and there it is. They do sum to 1. Yes, this table shows a probability distribution. If it didn't have all the probabilities here between 0 and 1, then we would say no. If all the probabilities did not sum to 1, we would again say no. If the random variables, which are my X's, the X's number values are not associated with probabilities, well, they are. And the random variable X is a category instead of numerical. No, they're numbers. Now, find the mean of the random variable X, select the correct choice below, and if necessary, fill in the answer box to complete your choice. We go to Stat, Calculators, Custom, and our values are in X. Our probabilities are in P of X. That's all I have. But that's all I really need, because now, look, it tells me that the mean here is 2.5. Round to 1 decimal place, perfect. There we go. And last, find the standard deviation. We have the standard deviation. It's right there, round to 1 decimal place. If I round this to 1 decimal place, I would have 1.1. And I showed you how to calculate it, but you don't have to calculate it. Question number 2. And let's open this and get our StatCrunch open. Let's read the question. Refer to the accompanying table, we have it over here on the left, which describes results from groups of 8 births from 8 different sets of parents. The random variable X is the number of girls. Find the mean and standard deviation for the number of girls in 8 births. Should we check to see if it's a probability distribution? We look at P of X. We don't want them to trick us. So let's sum the columns. It equals 1, so we know we have a probability distribution. And then we have to find the mean. We go to Stat, Calculators, Custom, all the way at the bottom. My values are number of girls, that's my X. The probabilities are my weights. I hit Compute, and the mean is, it's right here, round to 1 decimal, it's just 4. We can put 4 or 4.0, either one should make it happen. Yes. And the standard deviation, round to 1 decimal, is 1.4. And check answer.